staging area of the automotive data warehouse. The aim of this project was to provide end users information about the relationship between automotive brands in the world. And this project carried out a case study of 28 mobile brands across 3 continents in the world where these automobile manufacturers are based, such as Europe, Asia, and North America. So as we can, and the staging area is also the back-end area of the data warehouse where the ETL process takes place. So from this staging area, we can see that the all metric table here represents the structured data set, we can see, while the sentiment table here represents the unstructured data set, as we can see here. Then these were the codes in R that were used to clean these data sets, the unstructured data. I cleaned missing values, special values, outliers. Then this was the code that was used to extract and clean data from Twitter using R. So in this staging area, the clean tables, I created these clean tables with SQL statements to truncate the data from both of these tables to avoid data duplication. Three-dimension tables were created, such as rank dimension, brand dimension, and metric dimension, and similar process was used in the creation of the fact tables. I created three IDs such as rank ID, brand ID, and metric ID to map a primary to foreign key relationship between the dimension tables and the fact tables using inner join SQL statements that was used to integrate both of these tables together to ensure referential integrity and conformity. And the measures also from the dimension tables were also integrated into the fact table, such as the values and the opinions, overall opinions and sentiments from the users. The green ticks here indicate that the ETL process went successful and there were no errors. So the next step now will be the cube deployment. As you can see, this is star schema, my star schema. This is my fact table, my three-dimension tables like I explained earlier. The brand dimension has four columns: brand ID, brand name, country, continent, metric, metric ID, metric, and rank, just the rank ID. So like I said earlier, these are the three IDs that I created, and SQL and inner join was used to map a primary to foreign key relationships between the auto fact table and the three dimension tables, as we can see here. And these are the measures, like I said, that were integrated into the fact table. So the next process now will be to process the cube. As we can see, the cube has been successfully deployed with no errors. And other processes too were successful. So we close. Then the next thing will be to understand the data integration, the data distribution in Tableau. So this sheet has answers for business queries such as cheap maintenance, expensive maintenance, for and production. These queries were sourced from 7 different websites. In terms of cheap maintenance, we can see here that Lexus was the ranked second, the second cheapest car brand to maintain on an annual basis with 3,500 USD, followed by fourth on the list, which was Mitsubishi with 3,700, then Mazda. Then in terms of expensive maintenance, we can see that Cadillac was ranked third, the third most expensive car brand to maintain with an annual cost of 6,350 USD, followed by Chrysler at number 8. In terms of fuel, you can see that Smart was the second, ranked the second most fuel efficient car on the road, followed by Mitsubishi, then Mazda. Then in terms of production, Hyundai was ranked number 4 in the world with 38.2 million cars produced over the 5-year period. Then in terms of sentiments here, we can see the data distribution, and from here we can see had a Hyundai was the second highest in terms of overall sentiment scores, followed by Mazda, which was the first, 406. Then Volvo was number 3 with 260. Then Smart had the lowest